Hello everyone. In this Newton's second law series, let us look at the second important example, inclined plane. With friction, without friction. Initially, we shall do without friction. This is an inclined plane problem in which you can actually change the angle by moving this inclined plane. So the first video we have seen Atwood's machine. So I'm making the inclined plane at an angle of 30 degrees because it becomes easy, and mass M2 is set as 10 kg and mass M1 is 6 kg here. So I'm initially making coefficient of friction 0 and we are not considering any friction. So we are going to prove again what is acceleration and tension acting on the body. As we have seen in the previous video, the first step in finding out is the direction, is the where the body moves. So let me run the simulation. The body is moving towards down, M1 is moving down and M2 is moving up the plane, right? So let me reset it. So this downward direction is positive for the M1 and along the plane upward is taken as positive for M2. So let us first see the free body diagram before we look at the simulation. So free body diagram is basically all the forces acting on the body. So of the specific body, like let us suppose M1, we are looking at only M1. So one is the force acting on the body, obviously the weight downward, and the rope is pulling it in this direction. So tension is acting, it's a pulling force. So T is along this upward direction. Now, let me draw the forces acting on M2. This is obviously the tension acting on M2 and the weight acting on M2 is this side. And the normal force acting on this body is this to the surface always. And as we are not considering friction here, if we consider friction, the friction acts in this direction, But I'm not considering friction in this particular problem. So this is how the free body diagram is drawn. Let me just check the free body diagram in this simulation. Yeah, it is matching with this, right? Tension, M2G, normal reaction, M1G, and tension. Yes. So whenever the question says draw the free body diagram, remember one thing, we are not supposed to draw components of forces like M1G components, we are not supposed to. Now let us draw the components of the forces. Like on inclined plane, one more important thing is resolving component, weight component into two. So let me take a block of mass here, somewhere here, and then the weight acting on the body is perpendicularly downward. Yeah. So this is the weight acting on the body. And let's say this is the angle theta, and this is mg. Now the question comes, which is taken as mg cos theta and which is to be taken as mg sin theta. So when you resolve this component, there are two components. This is one and this is the other one. Now what to be taken as mg cos theta, what is to be taken as mg sin theta? For that one simple example, I'll tell you. Let me take this as 30 degrees. When you take this as 30 degrees, this is 90. When this is 90 and 30, the rest angle will be the total must be 180. So 90, 30, 120, 180 minus 120 is 60. When this is 60, again, this is going to be 90. So in order to making it 90, it must be 30. Now look at the 30 angle is matching with this angle, right? That means this 30 is equal to this 30. So whatever angle we take here will be equal to this angle. So this is theta and this is also going to be theta. Now the one which is close to angle is always horizontal component, which is mg cos theta, and this is going to be mg sin theta. So always remember mg cos theta is perpendicular to this plane and mg sin theta is along the plane. So let me draw mg cos theta here and mg sin theta here. This is mg cos theta and this is mg sin theta. And the arrow marks, the length of the arrow is also important because the length indicate the magnitude, because normal and mg cos theta will get balanced, so I should draw both of them with the equal length, which indicates that both are actually equal. There is no movement along this direction. The block is not jumping up in this direction. It is just sliding over this plane, right? Not along this direction. So whatever forces are acting along this y direction is actually canceling out. That means n is canceling out with mg cos theta. All right. Now let me take the forces acting along x direction on this, because the motion is happening in this direction, right? In this direction and in this direction. So let us write the body diagram and equations of the force acting on the net force acting on the two masses. So first mass, which is T acting upward, tension acting upward, and M1G acting downward. I'm drawing M1G with a longer length because I know this is sliding down, so this is going to be positive. So this force is dominating than this force. So we know the net force is equal to MA. So this is going to be M1G minus tension is equal to M1A. We can write this as, I am substituting M1 6 kg here itself. 6G minus T is equal to 6A. Now I am writing T as a subject, 6G minus 6A. So tension is equal to 6G minus 6A. Now look at mass 2, which is on the plane. So when you look at the mass on the plane, the movement is happening along this direction, and this is taken as positive direction because the movement is in this way. So tension minus mg sine theta I need to take, right? For mass m2. If this is mass m2, tension is acting this way, and m2 mg sine theta is acting this way, m2g sine theta. So this is T minus m2g sine theta. And of course, this is mg. And this is the normal reaction. All right. So m2g sine theta, T minus m2g sine theta is equal to m2a. And now let me plug in the values of mass m2 also. M2 is 10 kg here. So T minus 10g sine 30, right? Because angle is sine 30 degrees here. Sine 30 degrees is equal to m2a, which is 10a. Sine 30 is 1 by 2. So 10 into 1 by 2 is 5. So I'm writing 5g directly here, 10a. So tension is going to be 10a plus 5g. So the tension is same because the same rope is moving across the entire system. So tension is going to be same. So I'm equating equation 1 and equation 2 in order to find out tension. So let me equate 6g minus 6a is equal to 10a plus 5g. Okay. When you take 6a this side and 5g to the other side, that means 6g minus 5g is going to be g. So A is g by 16, 9.81 by 16. Let me check what is 9.81 by 16 giving me. 0.6125. So I'm taking it as 0.61 meter per second square. Acceleration is 0.61 meter per second square. Now I'm going to take one of the equations and substituting that in order to find out the tension. So I'm taking T is equal to 6g minus 6a. 6 into 9.8 minus 6 times 0.61. So this is going to be 6 times 9.8 minus 6 times 0.61. The answer is 55.14. So I am taking 55.1 Newton approximately. So these are the two acceleration and tension values. Let me erase off the remaining things and check whether I got the same answer or not as per the simulation. So here we took two free body diagrams and two simultaneous equations. By solving simultaneous equations, we get one term. and the term will be helpful in figuring out the unknown. So let me click on this and see. See exactly the acceleration is 0.61. Yeah. And this is 55.13. So I approximated as 55.1. All right. And let me run the simulation and check. If you look at the time and velocity also can be calculated, like in the previous video, v squared using equations of motion in a simple way. So let us try that as well. So when the body started from here to here, it covered this much of distance, 2.35. So displacement is 2.35 meters. And when in the beginning the body is at rest, the velocity we need to find out. Let us say v u is equal to 0 and we need to find out. We'll go with v squared is equal to u squared plus 2as because acceleration is known to us, right? So now v is going to be under root 2 into 0.61 times 2.35. Root, you will get 1.69 something, 1.693. So you might take it as 1.7 meter per second, which is exactly matching with this. Now the time, again, we use any equation of motion, v is equal to u plus at we can take. 1.69 is equal to 0 plus acceleration is 1 point, what is acceleration? 0.61. 0.61 times t. So t is equal to 1.69 by 0.61. The answer is 2.77. So exactly 2.77 seconds it falls down. So this is how we can solve the problems using the simultaneous equations and equations of motion for inclined plane. We follow the same steps. First, draw the free body diagram and guess the direction, and then draw the simultaneous equations and solve for the unknown. That's it. Thank you for watching.